So today we're essentially going to talk about the law of sines and the law of cosines. So we're going to learn like these two important laws. So this is what's on our agenda. Now, the law of sines is essentially, we're considering a triangle, and we have to draw this triangle. Okay. It's a triangle. And so where the angle opposite the side with length A, so this is length A, this angle here is labeled A. Opposite, the angle opposite the side with length B is labeled with a capital B. And the angle with the side with this length C, small c, the angle is labeled C. So you see that they're opposite each other. So the first thing is to draw your triangle correctly. And notice that the sides are small ABC and the angles are capitals ABC. And notice that they're opposite each other. So opposites. So if you don't set it up, the formulas get a little bit, you might mess up. So be mindful of that. Just drawing your triangle correctly. So again, it's just opposite of A. If the A's are opposite, the B's are opposite, and the C's are opposite. And again, the capital ABC are the angles, and the small ABC are the sides. Just repeating myself. Now, we learned before, we could find the area. So the area was given as a half. Let's go back to this side. So if we were looking at this angle, angle A, we have sides B and C and angle A. So the area of this triangle is therefore a half. The sides BC times sine of that angle A, which is also equal to, so this same area, now we're looking and focusing on angle B. So it's sides C and A with angle B. So I'll just write that down. So it's a half times, what was it? A and C. So I'll just put them A and C times sine of B. And the last one, if we're focusing on angle C, it's going to be sides A and B. So we're just applying that same formula that you probably used in your assignment. Okay, so we have three equations for the area. They're all equal to the area. So the area is therefore just equal to half BC sine A, which is equal to a half AC sine B, which is equal to a half ABC sine C. So we get this. Okay, well, we could cancel out the halves if we wished, like to cancel, or another alternative. So I'll erase that. Just showing you. We could divide by a half ABC. So if we divide this by a half ABC, we're going to get something. What are we going to get? So the halves will cancel, like I said, and we're going to get the first part, we're going to get sine of this angle divided by ABC. So the B and the C cancel. So it's going to be divided by A. the middle part, we're going to get the half will cancel. We have AC divided by ABC. So we're left with the sine of B divided by our B, or small b. And then we have a half AB sine C. We're going to divide by a half ABC. The halves cancel. The A and B are canceled. We're left with sine of the angle C on top divided by our C. So this is basically the law of sines, and we just showed it. We just kind of by the triangle. I don't want to just give you the law of sines. I want to show you where the law of sines comes from. So it comes from like these triangles. So let's just repeat. We just found the areas of these triangles, and we used that and focused in on the different angles to find the areas, and then we made equations, and then we have our law of sines. So this is the law of sines. Okay. So find the lengths of the sides of the triangle. I'll just repeat what the law of sines is up here, just so we remember. It's just the sine of A over side A, sine of B over side B, and sine of C over side C. Okay, so find the lengths of the sides of the triangle with one side of length 5 opposite to an angle 78 degrees and another angle of 38 degrees. So we begin, of course, drawing our triangle. So we draw a sketch. So let's read it again. So find the lengths of the sides of the triangle with one side is length 5. So let's label 5, opposite to an angle of 78. So this is 78 because they're opposite. And another angle of 38. So we could label this one as 38. Wouldn't matter if it's this one. Now, how are we going to get this other angle up here? Anyone? This other angle? Right? Yeah, exactly. So this angle over here is just going to be, because we know that angle plus 78 plus 38, this is going to be equal to 180 because those are the angles of interior to a triangle. And then we can solve this equation and clearly get, if you take 180, subtract 78, subtract 38, and we get, anyone? All right, thank you. 64 degrees. So 64 degrees. Perfect. Okay. Now, we're just going to apply, because it says find the lengths of the sides. So we want to find like these other two sides, obviously. So we're going to use the law of sines. And what did we get? Well, sine of 78 degrees divided by 5 is going to be equal to sine of 38 degrees divided by, let's call this x. And our last one is sine of 64 degrees divided by, let's call this one y. So essentially, we cross multiply and we can kind of solve for this. You can be working on this as I do it. To help us, what is the sine of 38 degrees? 0.62, right? And what is the sine of 64? 0.90. Okay. So we basically use a calculator for that. Oh, and the last one, sine of 78. That's 0.98. Okay, yeah. So use a calculator, obviously. To get those. I'll go back to another color. So we can look at the first part here. And we can solve for x. So we could cross multiply. Go back to blue. So x times sine 78 is equal to 5 times sine of 38 degrees. So this implies if we divide the left and right hand side by sine of 78, this implies x is going to be equal to 5 sine 38 degrees divided by sine of 78 degrees. We know that this is the sine of 38 by, we just did this up here, is 0.62 divided by 0.98. We're just calculating this, and we get x is, calculate it with me. Yeah. 1.4. Oh. Got 3.16. Maybe I put in the full number, or like maybe I put in the whole sine of 38 times 5 divided by sine 78. Anyways, so then your answer, it's close. So here is our x, approximately equal to, let's say. So we found our x here. And now we do the same thing to find our y. So, what color? So this part here. So now we're going to solve for our y value. So we cross multiply. So y times sine of 38 degrees. And then we have our x, but we found what our x is already. Actually, I'll backtrack a step. I'll write it out so you can kind of see it a little bit more clearly. So sine of 38 degrees divided by x is going to be sine of 64 degrees divided by our y. Now we have our x, so we can plug in what our x is here. This is 3.1, I think it's a 6, and we cross multiply. Maybe I should check.
I also got 3.147.
Oh. Yeah. Okay. So we could kind of or 7 could be rounded. Let's make it a 5. I have to fix a lot here. Okay, and now our y is just going to be, we're going to divide by both sides by sine of 38. And we get our y is approximately equal to, you guys can tell me. 4.6. Yeah, let's go with that. 4 point. One more decimal place. 5.9. Okay, good. So then we got our y here is 4.59. So I got that one right. Okay. So it's not drawn perfectly to scale. But in the next question, I'll try to draw it a little bit better. I just started off with a triangle because I didn't really know the dimensions exactly. Now for find, so let's go back. So when it says find the lengths of the sides, and we only had 2 angles and basically one side. And so to find the lengths, we had to find the other 2 sides. So we had to find all the sides. So find the angles in a triangle that has one side of length 6, one side of length 8, and a 97-degree angle opposite the side of length 8. So 97 is going to be more than 90 degrees, obviously. So let's try to draw this. Maybe like that. So this angle is 97 degrees, and opposite is side 8. And the other length is side 6. Okay. So we could, of course, you notice first, well, okay, let's first try to start solving for maybe this angle across from it, across from side 6. So we can use the law of cosines, or law of sines, sorry. So we write that down. So sine of 97 degrees divided by 8, because this is opposite, is equal to sine of this angle that we're searching for. We could call it theta, or we could actually label it with a, let's say, B. Divided by our 6. And we could label this other one A if we wish. So then we can solve for this. Again, it's the same idea. You can do it almost, but there's a little difference. So 6 times sine cross multiplying of 97 degrees is equal to 8 times sine of our B. We divide, and we notice sine of B is going to be equal to 6 times. So what is the sine of 97? I'm going to use my calculator. Sine of 97. 0.99 divided by 8 equals that times 6 divided by 8. So we get sine of B is equal to 0.744. Okay, so now what do we do? Sine of B is equal to 0.744. We want the angle because it says find all the angles. Go back to the question. What does it say? So what is our next step? Yes? Right, yes. We want to take that inverse. That second function is that inverse. So we want to take, I'll write in blue, we wish to take the inverse of this. So if we take the inverse, B is therefore going to be sine inverse of 0.744, which gives us the angle of B is approximately equal to 48 point something, yeah, degrees. So we can label that on now our triangle. 48. Great. Okay. So now, what do we do to find our A? Because the whole triangle has 180 degrees, we can find our missing angle A. So that's just going to be A plus our B plus our 97 degrees, and we can calculate this. This is equal to 180, which therefore implies A plus our B here was 48 degrees plus 97 degrees, which therefore implies our A is equal to, anyone? Just subtract. Yep, 35 degrees. And then we label it 35 degrees. Ta-da. Okay. So we kind of also observed something. Let's go back to the question. Take a step up. So this angle here is the largest angle. It's 97 degrees. It's more than 90 even. It's across from the largest side. So like these are across from each other. The smaller side is across from a smaller angle. So there's going to be that idea, because if you widen this angle up, then the side across from it is going to be larger. So it should, and the angle that's very small will have the smallest side across from it. There's going to be that pattern. Okay. So now let's talk about the law of cosines. Suppose, let's say we consider a triangle with sides of length ABC and an angle of C opposite side of length C. So let's just draw this triangle. So we have sides C, ABC, and across from C, we have like this angle C. Across from A, we have A. Across from B, we have B, angle B. Now, consider, so we drop a perpendicular line segment from this vertex opposite side B to length B. So just perpendicular like this. And this is 90 degrees. And we label this with an H. Now the endpoints of this line segment of length H divide the sides of B. This divides into two smaller segments, which we're going to call R and T, like this. Okay. Now I'm just going to redraw the picture a little larger because we're going to analyze it. Not the So we have, again, we have A, B, C. This is our angle B. This is our angle A. And this is our angle C. And what we've just done, we've taken B and dropped this perpendicular line. That's 90 degrees. Two triangles that are right angle triangles. And we have our H here. Now we can see by looking at this triangle, this first triangle, let's use a color. What color? I'll just see, lightly put it in gray. That sine of C so sine of C, remember our SOHCAHTOA is going to be equal to opposite over the hypotenuse. So opposite, I like to even write SOHCAHTOA over here. So opposite is our H divided by our hypotenuse, which is our A. Oh, and remember we B got divided into two parts, our R and our T. Now we can do this similarly for cos of C. So cos is adjacent, but adjacent is equal to T. So adjacent over A. So this, if we rearrange like these, is sine. This will imply H is equal to A times sine of C. And this cos one will imply T equals A times cos of C. So now we can label that. Let's put that. So our H here is A times sine of C. And our T here is A times cos of C. And our R here is going to be B, the whole thing, B minus our T, because it's the whole thing minus like, so whole B minus this part is equal to R by definition. So this means it's going to be our B minus our T, and our T is equal to this, A cos of C. Okay, so that's our picture. Okay. And that's what I'm saying here in words. So if you wish to read it. Let's just redraw it one more time. Same picture. Go a little faster. So we have our A, our B, and our C, and our angles. C, C, A. We have our line. And we have our H here is equal to A sine of C. And our R here, this part, this segment, is equal to B minus A cos of C. And this segment is equal to A cos of C. And this is equal to our T, and this was equal to our R. So we have two right triangles. So we have a right triangle on the right and one on the left. Okay. Now, just so you can clearly see the two triangles. I can even color it, like lightly shade it in gray. This one. And I'll shade the other one in like a green. So we have a right one and we have a left one. So let's consider the right triangle. Well, we could consider anyone. So we're going to apply Pythagorean theorem to like this expression for C squared and use the identity to essentially simplify it. So if we remember, this is equal to, so c squared. And if I go back, looking at, let's say, the left triangle, so c squared plus h squared plus r squared. So r squared is equal to b minus a cos c squared. So let's write that down. So that's going to be equal to b a cos of c all squared plus, let's go back, our h squared. Our h is equal to a sine c plus a sine of c squared. Okay, so now we have to do some math to simplify this, or expand it first and then simplify it. So c squared is equal to, this is just like multiplying any two binomials, sort of. So a b times b is b squared minus 2 ab cos c plus a squared cos 2c plus this squared. Now this is a squared sine squared c. Just going to write the same thing, just rearrange the terms. This is b squared minus 2 ab cos of c plus a squared cos squared c plus sine squared c squared. This part all here is equal to 1, because by that identity. So that makes use of that identity. And then we get the cosine law, which is c squared is equal to rearranging a squared plus b squared, subtract 2ab cos of c. Ta-da! All this work, and we just showed the cosine law. Instead of just giving you the formula, it's nice to know where these formulas come from. Okay. Pardon?
So the c squared equals b squared.
Yeah, c squared equals a squared plus b squared minus 2ab cos c. That's the whole cosine law. And then it's written in the slide too, as a summary. So if you have sides A, B, and C, and the side opposite of angle C with length C, this is the cosine law, where we're focusing essentially on our C. Now, what if we focused on B? So let's say it this way. Focusing on B, we can rearrange this. So now instead of cos C, we want cos B. So this means the C's are replaced with B's, etc. So then it would be B squared equals A squared plus C squared minus 2AC times cos of B. And if we were focusing on the other letters, A, focusing on A, we would get A squared is equal to B squared plus C squared minus 2BC times cos of this angle A. So these are the cosine laws. So it depends on what you're focusing on. If you have, like, let's say, particular angle then opposite would be over here. Just noticing that pattern. You can ask yourself a question. See what happens with the law of cosines when C is equal to 90 degrees. What happens? I'll put these in a box. I'll just give you a second to think about it while I box this. And this is a very super useful, important formula. So what happens when the C, this cos, is 90 degrees? What is the cos of 90 degrees? Yeah, it's 0. So this becomes 0, and we have C squared equals A squared plus B squared. So this implies that Pythagorean theorem is just a special case of the cosine law. So that's the point. Let's try to get you to say. So it's just a special case. So this is why it's so useful. So let's apply it some more. So the triangle with sides of length 5, 6, and 9. Let's draw a triangle. And you can do this along with me as I'm writing the solutions up. So we have 9, let's call it C, 5, let's call it A, and 6, let's call it B. Just so we're using the same numbers. You could do any which ways, it's still right. It's kind of arbitrary. Now let's just apply the law of cosines. So this is C squared equals A squared plus B squared minus 2AB cos of C. Okay, we could bring these over to the side because we have numbers for the sides. And then we can, of course, divide by a negative 2AB. So we got C squared minus A squared minus B squared divided by negative 2AB is equal to cos of C. Okay. And we have numbers for A, B, C, so we just plug them in, essentially. So this becomes 81 minus 25 minus B was 6, so this is 36 divided by negative 2 a 5 times 6 is 30. I'll just skip a step. This becomes 60 equals cos of C. We do the math and we get 20 divided by 60, negative 60, equals cos of C. This is equal, obviously, negative 1/3. And then we can find our C doing that inverse. So cos inverse of negative 1/3. And you get approximately, this is equal to, anyone? 109.5? Anyone? 109.5 degrees. And I'll leave the other one for you to do. So exercise. Find A, and then find B. And it's the same thing. Okay. 2 more questions. So a triangle has sides length of 6 and 4 and an angle 35 between those sides. Find the length of the third side of the triangle. So we draw our triangle. So A is equal to 4. Let's say across from this angle, 35 degrees. We're trying to find this side C. And we have the side B equals 6. So we just apply the law of cosines. So C squared, just going to be 4 squared plus 6 squared minus 2 times 4 times 6 times this cos of that angle of 35 degrees. We can compute these numbers. This is approximately 0.82, I think, maybe. And we get C squared is equal to 12.7. Take that square root. 12.7. Now we would just want the positive one, obviously, because the side doesn't have a negative. So it'd be 3.6 would be approximately this side. We don't want that positive. We just want the, or we don't want the negative. We want the positive because obviously can't be negative. Now, when to use which law? So the law of cosines, you know the lengths of all 3 sides of a triangle, or the lengths of 2 sides of a triangle and the angle between them. The law of sines, you know 2 angles of a triangle and the length of one side. There's one last question I'd like us to do. It's kind of interesting. So suppose radar at an air traffic control tower shows the distance to an incoming airplane. It's kind of an important example. At 7 kilometers. The distance to an outgoing airplane is 11 kilometers, and the angle incoming to the tower is 37 degrees. How far apart are the 2 planes? Yes. So let's just draw a picture. Or do we have the time? Oh, okay. I guess I'll stop